Hello, today we're going to continue talking about translations. We'll be starting by looking at rules once again. That's where we left off last time. So a rule for a translation looks a lot like what you see right here. It always starts with x, y, and then an arrow, and then what we do to x and y coordinates. So this translation right here, x, y goes to x minus 6, y plus 3, means that we subtract 6 from x and add 3 to y. So we will use this rule to either find the image after we've done that translation or the pre-image of something that's been already had that translation done to it. Let's take a look at a few examples. So this first one says, what is the image of A15? That means we need to still do that translation to find what that image is. So what I'm going to do is, since this says subtract 6, I'm going to subtract 6 from my x coordinate. Since this says y plus 3, I'm going to add 5 to my y coordinate and then actually do my subtraction and adding. 1 minus 6 is negative 5. 5 plus 3 is 8. So the image of A5, we know the image gives us A prime. A prime is going to be those two coordinates we just ended up with, negative 5, 8. If I do this translation, A transforms into A prime with these coordinates. Next one's the same idea, which is a different starting point. What is the image of B, negative 2, 4? So I'm going to do the same rule. I'm going to take my x coordinate and subtract 6, take my y coordinate and add 3, although I got a little carried away there. When I do that, I get negative 8, 7. So then the image of B, once I do the translation, is B prime, negative 8, 7. These other ones, we are going to work backwards because they're asking what the pre-image is. This is C prime. What was the point C we started with? So we need to do the opposites of our rule. So our rule says to subtract 6 from x. We're actually going to do add 6 to x. And our rule says to add 3 to y. The opposite is we subtract 3. So very similar to what we did here, we just have to do the opposite of the rule. So to get my original point C, I'm going to do negative 1 plus 6. Again, the opposite of my rule. And I'm going to do my y coordinate negative 7 minus 3, the opposite of my rule. Negative 1 plus 6 is 5. Negative 7 minus 3 is negative 10. So since I have C prime, we wanted my starting point C. My original starting point C, its pre-image was 5, negative 10. Number 4 is the same idea, just with a different point. We're going to do the opposite of the rule. So I'm going to add 6 to my x coordinate. I'm going to subtract 3 from my y coordinate, which gives me the point 8, negative 8. So the pre-image or starting point of D prime is going to be D, 8, negative 8. We can also use a rule to transform a quadrilateral. And anytime they give you coordinates, especially if it is with a quadrilateral or triangle or something like that, it's a really good idea to use Desmos, especially if you see the word graph there. So anytime you see the word graph, use Desmos, and on your homeworks, just send me a screenshot or upload a screenshot of your picture of your graph. So what I'm going to do first is I'm going to graph my vertices, aka the corners, of my quadrilateral in Desmos. Remember, to graph in Desmos, you just type in the ordered pairs exactly the way you see them. Negative 1, 2. If you'd like to label that, you can click label and type in the name of that point, which is A. And I'm going to do this for the rest of my points here. I'm going to label all of them to help me keep myself organized. There's my starting quadrilateral. It's like a trapezoid. We'll talk about those later. And then we want to find its image after the translation using this rule. So our rule says add 3 to x and subtract 1 from y. So what I'm going to do is I'm going to do just like I did back here in number 1 and number 2, is I'm going to find my image points. So starting with A, I'm going to add 3 to my x. I'm going to subtract 1 from my y. That gives me 2, 1. So A prime is 2, 1. I'm going to do all of those first, and then I'll do all my graphing at the end. B, this starts with the point -1, 5, but I need to add 3 to x, subtract 1 from y. So I get 2, 4 when I do that. That'll be my B prime. C, same idea. Add 3 to x, subtract 1 from y. I end up with 7, 5 for C prime. And then last but not least, D. I'm going to add 3 to x, subtract 1 from y. I'm going to get the 0.71 for D prime. So now I'm going to put all of these into Desmos. 2, 1, and to label it as A prime, I'll move this here so we can see it. If you go to your keyboard, your ABC button, and you do Shift, you get your prime button by using your comma key. So it gets goofy when I try to do that here from the computer, so I'm just going to type it in. And we'll do that for the rest of your points. Of course, make sure you type in the ordered pair first and then label it. I always try to do it the other way around because my brain gets goofy about it. And last but not least, D prime. And so if we look carefully at our picture, A, B, C, D is my pre-image, A prime, B prime, C prime, D prime is my image, what happens after I translate. We are going to continue on with some more talking about translations. And so just some more kind of vocabulary and conceptual stuff. A rigid motion is a transformation that preserves length and angle measure. And sometimes if you want to get really fancy with this, we call this an isometry. It means the same thing. What a rigid motion does is it takes a point, line, figure, segment, whatever you're dealing with, and keeps the length of each side the same and all angle measures the same. This right here is an example of a rigid motion. Each corresponding segment has stayed the same length. Each corresponding angle has stayed the same size. Translations are always rigid motions. And if we do more than one translation, which is called a composition of transformations, that will also give us a rigid motion as well. So if we take 2 rigid motions, we will still end up with an overall rigid motion as our final result, no matter how many rigid motions you do. When you have a composition of transformations, it's going to look something like this, where they have translation, one rule, translation, new rule. And so you're going to be doing more than one translation. So this is very similar to what we just did, except for we have a triangle to start with, and we are going to be doing 2 translations to it. So I'm going to start by putting my original coordinates of my triangle into Desmos. So I have -2, 3, which is P. I have 1, 2, which is Q. And I have 3, -1, which is R. Triangle there. Not a very wide triangle, pretty skinny triangle, but still a triangle nonetheless. What those translations mean is we're going to do exactly like we've just been doing, but we have to do 2 of them. So I'm going to start with this first translation right here. XY becomes X plus 12, Y plus 4. So I'm going to write my work for that down here. To transform P, I'm going to do -2 plus 12. I've got all kinds of weird punctuation here. Sorry about that. -2 plus 12. And then I'm going to add for my y coordinate, so 3 plus 4. When I do that, I get 10, 7 for P prime. I'm going to do that to my other 2 points as well. Add 12 to X, add 4 to Y, which gives me Q prime 13, 6. And last but not least with R, add 12 to the X coordinate, add 4 to the Y coordinate, and I get 15, 3 for R prime. I'm going to put those in Desmos. I'm going to label them just so I can kind of keep things straight. And last but not least, R prime. I'm not done yet though, because it just wasn't just one translation. We have a composition or two translations. So now I'm going to do that second translation. And I'm going to write the work for that underneath. The second translation says, take these new points, subtract 5 from X, subtract 9 from Y. So I'm going to do 10 minus 5, 7 minus 9, again, starting with this point here. And that gives me 5, negative 2. It's not going to be P prime because I've already, so anytime we do another transformation, we add another prime. So this becomes P double prime. That double prime means I've done 2 things to P. And we'll do the rest with these points. I'm going to take 13, 6, subtract 5 from the X, subtract 9 from the Y, which gives me 8, negative 3. And we're going to call that point Q prime. For R prime, I'm going to do 15 minus 5, 3 minus 9, which simplifies to, that is the wrong number there, 10 and negative 6 for R double prime. So then now I'm going to graph my R P prime, P double prime, Q double prime, R double prime in Desmos. 5, negative 2. Just use 2 prime symbols here. 8, negative 3. Q double prime. And then R double prime. And I'm going to move my screen here so we can see both triangles. Here was our pre-image. P prime, Q prime, R prime is what happens after the first translation. P double prime, Q double prime, R double prime is what I get after the second and final transformation. So that would be my final image. The size of the triangle stays the same. The angles within the triangle stay the same. We've just slid it around the coordinate plane.